Pilots who've flown the A-10 know it is nicknamed the tank opener, for good reason. A low-altitude demon. Its heart is this massive cannon. Others get planes with guns. This is a gun with wings. The A-10 has a 30mm Scout-8 Avenger Gatling gun, weighing 1.76 tons when fully loaded, accounting for 20% of the aircraft's total weight. One of the largest airborne cannons ever. The entire plane is built around this weapon. The Gatling system features 7 rotating barrels, each with its own chamber and bolt. Behind the barrel is a fixed housing with a cam path, which engages with the bolt as the barrel rotates, enabling the loading and chambering of rounds with each rotation. And firing. The cannon fires 4,200 rounds a minute, but is later reduced to 3,900 revolutions per minute to prolong barrel life. The distinctive sound of the A-10 comes from its extremely high rate of fire. The bullets fire travel at 900 meters per second, roughly 3 times the speed of sound. The A-10's Gatling gun is mounted slightly offset to the left. The firing mechanism is centered on the main barrel. This design prevents the massive recoil from the cannon. To avoid deviation, behind the Gatling cannon is a large ammunition chamber, capable of holding 1,200 rounds at once. Though combat loads typically range from 750 to 1,174 rounds, the cannon fires very large shells, with rounds up to 290mm long. The magazine was very heavy. Since the magazine is positioned forward in the aircraft, as ammunition runs low, the aircraft's balance will be severely affected. To address this issue, spent casings aren't ejected, but retract on rails into the magazine, maintaining the aircraft's balance with an added advantage, preventing shell casings from entering the engine and causing hazards. The actual cannon's ammunition configuration is also unique, typically alternating armor-piercing rounds with high-explosive incendiary rounds every 5 shots. Armor-piercing rounds use depleted uranium, which has low radioactivity, but when armor-piercing rounds hit enemy armor, the projectile's tip collides with the target at high speed and fractures, forming a new sharp edge to maintain continuous penetration capability. Simultaneously, upon impact, fragments ignite upon contact with air, triggering explosions in the tank's ammunition or other combustibles, delivering devastating damage to the tank. Besides the cannon, the A-10 carries 7.2 tons of weapons across 11 hardpoints, with 8 under the wings and 3 on the fuselage. These hardpoints can mount various armaments like laser-guided weapons, GPS-guided weapons, and various missiles. After learning about these armaments, we're entering the A-10 cockpit. To see how the A-10 is piloted, you can observe densely packed buttons and displays throughout the cockpit. These 2 are color multifunction displays with moving maps, while below are the throttle and control stick, respectively, which are similar to most fighter jets. To start the A-10, first activate this battery switch. Then set the inverter switch to standby mode. After configuration, all electronic systems in the cockpit will power up. We can check the health status of the aircraft's key components based on the device displays. Note that the battery can only power some devices in the cockpit, but it cannot start the engine, as the engine requires pressurization first. Therefore, we need to activate the auxiliary power unit (AP) here. At this point, we just wait for the right fuel pressure light to turn off to confirm the fuel pump is operational. Once the APU is ready, we can start the engine. First, we turn on the left engine start button. After the engine starts, we need to closely monitor the engine instrument data. Once running normally, we can then press the start button for the right engine. When both engines are running, the APU will automatically shut down. The plane will begin to taxi. During takeoff, we first extend the aircraft wings to achieve maximum lift, simultaneously pushing the throttle to maximum and releasing the brakes, allowing the aircraft to accelerate for takeoff. After accelerating for about 300 meters, we need to check if the engine RPM reaches the expected level, and if confirmed, we'll make the final sprint. Then we need to slowly pull back the control stick, which will cause the A-10 to pitch up 10 degrees as it accelerates. Finally, the plane took off. Once airborne, we can retract the landing gear. When reaching designated speed, the wings will also retract. We can freely maneuver the A-10. The A-10 has strong landing gear and low-pressure tires, allowing it to perform takeoffs from highways, even on unpaved sandy terrain, which regular fighter jets cannot achieve.